Are you there? Okay. The next one is the next difference between strong and weak electrolytes. Examples under strong electrolytes, right? Examples of strong electrolytes are sodium chloride. In bracket, you write the chemical formula NaCl. Sodium chloride in a bracket NaCl, comma. Next one is what? Hydrochloric acid. Hydrochloric acid in bracket HCl. Hydrochloric acid in bracket HCl. Are you there? The next one, put comma, potassium trioxynitrate 5. Potassium trioxynitrate 5 in bracket KNO subscript 3. In bracket KNO subscript. That N should be capital, not small letter, please. NO then subscript 3, subscript. No, what you wrote is superscript. See subscript here now. Sub is under. Are you following me? What I say is the old name, a cake name for potassium trioxynitrate 5. Potassium trioxynitrate 5. The old name. Potassium nitrate. Please note, even though it's old name, please note them, because sometimes some question may come and they may be at that old name. Okay? See it here. Potassium nitrate. Okay? Alright, so let's continue. The next one, the next example is tetraoxosulfate acid. Tetra formula is H subscript 2 S O subscript 4. Tetraoxosulfate 6 acid is another example of a strong electrolyte. What does say is another name for this? What does it is old name for it? You have forgotten. Sulfuric acid. Sulfuric, look at it here. Sulfuric what? Acid. Is it clear? Sulfuric acid. Please note these things, okay? Okay? Please note this is sulfuric acid. You not get this special, you know. See it here. See it here. Sulfuric acid. SULFURIC. Sulfuric acid. Are we together? These are some of, after that we write ETC. These are some of the words, examples of strong electrolytes. Let's look at some of the examples of weak electrolytes. Some examples of weak electrolytes. Ethanoic acid. Ethanoic acid. C is spelled here. Ethanoic acid. The formula is CH3 COOH. Ethanoic acid. This acid, and this is IUPAC name. The old name is acetic acid. Acetic, yes. That's the Archaic name or old name. This one is IUPAC name. Acetic acid. Acetic acid. Another example of weak electrolyte is ammonia. See the formula for ammonia. NH3. Substitute 3. Ammonia. Ammonia. Are you there? Good. Just ammonia. Just leave it as ammonia, okay? Next one is you find out which one is next one is carbonic acid. Carbonic acid. Carbonic acid. In fact, let me not cut you short. I like the question you ask, but I'll give to you as an assignment. Carbonic acid. Find out whether it is IUPAC name or old name. That's the formula. H2CO3. Find out whether it is IUPAC name or old name. If this one is old name, find the IUPAC name. If this one is IUPAC name, find the old name. The same thing with ammonia. Do it for total. I like that question. You show that you are following. I'm impressed. That's good. I hope we are following the class. So find out two of them in the next class to tell me, okay? I think we have chemistry tomorrow. You tell me tomorrow. Alright, so now these are some of the examples of weak what? Electrolyte. Now there's another thing I want us to look at. We have roughly 10 minutes to end this class. I want us to look at the next subtopic. Next subtopic. Are you there? Next subtopic. Electrolytic cells and electrochemical cells. That's our next subtopic. Electrolytic cells and electrochemical cells. Electrolytic cells and electrochemical cells. That's the next subtopic. Are we together? Good. Did you remember there was a diagram I drew where you have two electrodes in electrolytes and it's connected? That is the electrolytic cell. And that is where the cell used to carry out electrolysis. So electrolytic cell is designed to carry out what? Electrolysis. So you want to compare between electrolytic cell and electrochemical cell. They are not the same thing. Electrolytic cell is for electrolysis. Electrochemical cells are all those batteries you use. Battery used in your charger, torch, all those things, even vehicles. These are electrochemical cells. But a electrolytic cell is different from a electrochemical cell. In fact, they are opposite of each other. By the time I go deep into the differences, you understand. They are opposite of each other. So these are the terms you are going to be encountering. So I'm trying to explain them. I have already explained the content of in an electrolytic cells. You see your power source. Let me draw it again. You see your electrolyte, right? You see it, right? You see your what? Electrode, right? You see your power source. One of them is cathode, which one is what? Cathode. You see your power source is connected. to electric source, okay, electric current source that will send electric current inside this place, okay. Remember, when inside this once in this solution form, normal sodium chloride, which is solid, is already dissolved. When it's like this, but when it dissolves with water, inside water, it will remember, water has water is polar, dipole, partially positive and partially negative end. So once it's mixed with water will now impact this inside in this sodium chloride, that putting it inside that sodium chloride, it will develop this partial end, partially positive end and partially negative end as a solution. As a solution, it's not like this again. As a solution, it appear like this. This is aqueous, this is solid. This sodium chloride here is solid. But when you mix with water, which is polar, that has partially positive end and partially negative end, it forms aqueous. Giving aqueous solution, giving it positive end and negative end. And sodium bears that positive end, chloride bears that what? Negative end. It's like this in this electrolyte. When you now pass electric current, it will separate totally into sodium ion and what? Chloride ion. Another ions inside though, we have hydrogen ion is there and oxonium ion. Now when you go into the electrolysis fully, you understand this, but just let's focus on what? Sodium ion and the chloride ion. So when electric current is passed, sodium ion will separate from chloride ion, and sodium ion will now go to what? Cathode. Chloride ion will go to what? Anode. Don't worry, this is exactly what happened in electrolytic cell. So this one is electrolytic cell. So now let's go to the put down note. Let's differentiate between electrolytic cells and what? Electrochemical cells. Are we together? Good. So you can draw a table again. So start with electrolytic cells on the right, on the left side, electrochemical cells on the right hand side. So electrolytic cells use an external power source. Electrolytic cells use an external power source to drive a chemical reaction. Look up. Have you seen that? This is the external power source. It needs it to be able to drive this chemical reaction that will form sodium and chlorine gas and maybe hydrogen gas, depending on the one that is preferentially discharged. When you go into electrolysis fully, you understand it. Go to electrochemical cells that drive chemical reaction. Go to electrochemical cells Are you there? Electrochemical cells harness Harness. Electrochemical cells harness energy from a spontaneous chemical reaction. Electrochemical cells harness energy from a spontaneous chemical reaction. In another word, continue. In another word, the reaction is spontaneous. Have you seen it now? The reaction is what? Spontaneous. But under electrolytic cells, right? In other words, Right, in other words, the reaction is forced. It's a forced reaction. You force it to occur. Is it clear? Yes. Because you need external source. Without that external power source, it cannot place. So you force it to take place. Is it clear? Spontaneous. Now, go to number 2. The reaction in an electrolytic cells. Sorry, the reaction in not and please cancel that and. The reaction in electrolytic cells. The reaction in electrolytic cells is non-spontaneous. Is non-spontaneous. Non-spontaneous, comma, meaning it would not occur. Meaning it would not occur on its own. Meaning it would not occur on its own without the external energy source. Meaning it would not occur on its own without external energy source. Meaning it would not occur on its own without external energy source. Meaning it would not occur on its own without external energy source. Is it clear? Go to electrochemical cells. Go to the, are you there? The reaction in electrochemical cells. The reaction in electrochemical cells. The reactions in electrochemical cells wait, this thing should be with this and this should be with this. Okay, put arrow here. This, remember we are comparing, so this we will be to compare with this. Is it clear? And this one will compare with this one. Okay, that's a mistake from me. This will compare with this, because here, remember in an electric cell, we said it required external source. Okay, so but this one is self-sustaining. So but this one is spontaneous, not spontaneous. This one is what? So this should be to this and this to that. Please correct it, or should I call it again?
Okay, so right.
Should I dictate it again, or can you do that on your own? Can you?
Should we write it somewhere?
No, okay. Just let me. Can I dictate again, or you can do it on your own? Okay, give space after you do it. Just know after you do it. Let me go to the second one. I say that the reaction in an electrochemical cells is self-sustaining. Is self what? Sustaining. Self hyphen source is self-sustaining, comma, meaning it occurs on its own. Meaning it occurs on its own without an external energy source. I think I'm correct too. This one, it cannot occur on its own, right?
Yes. Cannot occur on its own.
It cannot occur on its own, right?
Yes.
Harness from this one derived from chemical. Okay, it's correct. It's correct. All right, let's continue. The third one. You now do you understand what happens here? But in electrical cell, it occurs on its own, right? It doesn't need external power source. Is it clear? Number three. Go to electrolytic cells. Electrolytic cells are used for electrolysis. Electrolytic cells are used for electrolysis. Of course, you know what electrolysis is, so no need explaining electrolysis again, right? Now, go to electrochemical cells. Electrochemical cells are used to generate electricity from chemical reaction. Have you seen it now? So electrochemical cells are used to generate electricity, while electrolytic cells are used to do what? For what? For electrolysis. Is it clear? Now let's go to the examples of number 4. Number 4. Examples of electrolytic cells are those used in the electrolysis of water. Used in the electrolysis of water, electrolysis of sodium chloride solution, sodium chloride solution, electrolysis of dilute H2SO4, H2SO4, SO4, subscript, etc. So I just gave examples of electrolytic cell, the one we designed for each of these substances. Is it clear? Now go to examples of electrochemical cells. Examples of electrochemical cells. A typical example, they are the batteries. Batteries we use on examples are batteries. Batteries such as alkaline or lithium ion battery. Such as alkaline or lithium, LITHUM, lithium ion batteries, full stop. These batteries convert chemical energy to what? Electrical energy. This battery converts chemical energy to electrical energy. So I think we'll stop here for today. Do you have any question? Are you sure? You understood everything we discussed today? Remember the assignment I gave you. Make sure you go through the assignments. Okay? If you have any question, feel free to ask. You have my contact, right? Feel free. If you have any question, feel free. Okay? Make sure you study. Which textbook do you use in chemistry? Essential. Okay. It's okay, it's not bad. Make sure you go through your notes, go through your textbooks, and you are good to go. Fear not. Even though it's been long you left chemistry, fear not. Okay? Thank you very much. God bless you. See you tomorrow.